Good morning. Okay, so what we're going to do in lecture today is we are going to briefly discuss the concept of function overloading. We're going to go a little more detail into how it is that we could use several types of functions called with the same function name and when we can't do that. And then what we're going to spend the majority of lecture doing is discussing an idea called a C++ class. Now, C++ class builds off of the idea of a C structure, but it also provides encapsulation for what we're going to call methods. So we had struct members that were objects, so we could do doubles for point, and then we could make points for a line. So we had struct aggregation. We're going to do the same thing for classes. And what this is going to allow us to do is to hide some of the work that's going on in the code. And that's we've discussed this before, that's known as abstraction. So the first thing I want to discuss is function overloading. So previously we talked about this idea of classes, templates. So a template is when we were able to make a generic variable and call it template class T, and we could have the exact same function and just replace the variable type that was going in. So for example, if I wanted, we had a print function, and I could do a template with an overloaded int, float, and standard string. We saw an example of that on Wednesday. But what happens if I want the same function to potentially have multiple inputs or completely different operations based on that input? So a template is when I change the input variables, and based on those input variables, I produce the same thing over and over again. Whereas with function overloading, we're going to see examples where I can say a function name, and it will have two distinct function declarations based on what I would like it to do. And so here are some rules for function overloading. We're going to say that the preconditions must be different. And the preconditions are the inputs to the functions. So we can't have two functions that are overloaded being the same. And we're going to talk about how we have to have return types match. Second, you cannot use a function overloading to return a different type if the preconditions are the same. So these two are kind of rule 1A and 1B of the same rule, which is that you can't have print function and then have an input int, and then have one version return void and have another version return standard string, for example. And I'm going to show you on the next couple of slides examples of good examples of function overloading and bad examples of function overloading. The third rule is you cannot change a variable using reference or const for overloading. So if I have an input on one version of a function where it's just int x, if I try making a different version where it's int &x for a call by reference, that's going to throw a compiler error. Likewise, if I have one that's an int and I have a second input that's const int, that is also not going to work. I'm going to go over some examples of why that doesn't work. Right, does anybody have any questions on the basics of function overloading before I go into how these actually work? Let me check the chat real quick. Okay. Okay, first good example. Here we have the same return type. The function is called print me. And in one version, I have int temp x, and I have another one, string x. And the thing that's different about this than templating is that I could have, based on the input type, do two different things. Whereas with the template, it does the same thing, it changes the type. So this allows us more programming flexibility based on what it is that we would like to do. Now, here are some examples of bad function overloading. So if I have void print me, here's bad example 1, and here's bad example 2. So int print me int temp x and double int temp x. So a couple slides ago, can anybody tell me why this is an invalid function overload? Yes. Absolutely. You cannot return different types if you have the same precondition. So very good. That's 100% correct. Okay, second, we're here on the right. And let me see if anybody in the chat has a right answer. Can anybody on the chat tell me why it is that the two function declarations, or anybody who wants to unmute, why is it that these two are a bad example of function overloading? Anybody there? All right, there we go. I know it's getting one. Cannot use reference for overloading. So Daniel is absolutely right. We cannot use reference for overloading if we have a previous version that isn't overloaded, that isn't called by reference. Does everybody see that? Yes.
So I understand the first example because like it's kind of ambiguous, like if you're I don't understand the reason for this.
And I'm going to explain in detail why in a moment, and I'll get back to you when we get there. Okay, so here's a good example of function overloading. And in this particular function, we have 3 print me's. I have a print me standard string, I have a print int, and I have a print standard string and an int on the input. So this is in the file funcover, if it ever actually shows up on the screen. There we go, funcover. And here I have print me, and here it will print out the string, right? And here for print me, it'll print out int I. So you can see how I'm actually changing the functionality based on the input. So this is different than templating. And then here, if I have print me standard string and int, I can actually print out both of them. And then in main, see, I've defined a string. I've called the string version, I've called the int version, and then I called the string and int version. So what I'm going to do is I'm going to run make func over, and I'm going to run the executable. And we see that it calls the first version of print me in string. Then it prints the int version when it calls just int. And then hello world, and it prints out both of them. So now let's go back over this advanced example of reading in from the command line where I wanted to prove whether or not something was an answer. So if we go back here, I can do get value. And if I go to cin function overload, what this is going to allow me to do is I can have bool no bad cares. And then I can have a get value for an int. Now this is where the function overloading can play, because I can call by reference here because I want to return it there. And so I would input the integer. I would run everything that we did last time. And then if I read in successfully, it will return with the call by reference. Here I can do get value and I can do unsigned with the call by reference. I'm doing the same thing. Now notice how I'm taking advantage of the precondition and the call by reference. So that way I don't have the same preconditions with different return types. Does everybody see that? So this is, by doing this call by reference here, that is a design choice. That allows me to be able to take advantage of the C++ functionality to be able to write different versions of the get value function. And then finally, I had a float version. and it was slightly different. So the logic inside each of those functions was slightly different. And this allows me to write the same function name. Whereas in C, I had to write 3 different functions with 3 different names. And so here, this is an example of the benefit. When I am calling this, I have get value, I have the string that I want to pass, and the variable type that I want to read into. So now I'm just getting value, getting value, getting value. It's much easier for someone reading this code to understand what it is that you're trying to do. And how this benefits is that if you have different types that you want to do different things in, you can just make little tweaks to those functions and use the function overloading. So when I run make cin func over, we see that we catch my mistake. And so now I'm able to take advantage of this functionality and take advantage of the function overloading to make it more clear to the programmer or to the person who's reading the code or the programmer what it is my intention was. Okay, function overloading pitfalls. And this is going to be where I'm going to address your question in a lot of detail. So, students are trying to come up with designs, they're trying to come up with different ways to implement function overloading, trying to make it clear what it is that they're using. And the things that I said is you can't use const, call by reference, or int. So what I'm going to do is I'm going to show you this code, and I'm going to zoom in and show you the difference between these. And the key thing that we need to bear in mind is variable scope and what it is we're allowed to do given the call by reference and given the const. So on the left, we see print int. Correct? In print int, it passes by value. I increment I by 2 and then I print it out. Right? In the middle one, I call by reference. I increment 2 and I print it out. Now, why would this be a problem? Anybody have any? Yes. Absolutely. The compiler is not sure. We call that ambiguity. So I have ambiguous in big in italics right there. So what happens is in the first version of print int, if I pass 7, 7 becomes 9. It will print out 9, and then after the call, it will be 7 again. Whereas with print int, it'll be 7. 7 is added, it becomes 9. It prints 9, but when we go out of scope, that variable that we pass to it will be 9. In C++, we call those two functions the exact same way, just with print me, and I'll just say X, right? So the goal of call by reference is to take out the middleman, make these pointers less complex, right? However, this causes an issue. We end up calling those functions the exact same way, and therefore, if we try to overload these two, it becomes ambiguous and the compiler cannot tell which one is which. Does that answer your question? Does anybody else have any other questions before I go into the const? I like to also check the chat. On the right-hand side, we have const int I. Does anybody see a big issue with this version? On the inside, it's the exact same. But what's the issue with this version of the code? Yes. Okay, so const in I. Here I can pass values to a function that are const, meaning that it is the appropriate scope. But the thing you're talking about so let me ask this a different way. So the reason why we have const int that we put in header files, right, is so that they have the same value all throughout the function, which means they cannot be changed. If anybody tries to change them, that'll cause a problem. So let me follow up on that. So I could see your eyes light up from the back. So what is the issue with this code now? Absolutely right. I am passing it here, and now I'm trying to change it. So I have a version of the code that's trying to change it and it would stay in scope. I have a version that's trying to change it, but the scope changes. And then I have a third version that's const, and it's not going to allow that version to change it at all. So this has all kinds of problems. And in the file ambig.cpp, I have all three of these functions. And you can see, if you study it later, in giant comments, a deliberate compiler error, and I describe what's going on and why. And in main, I call all three of them the exact same way. The compiler cannot tell the difference based on how we have this set up. Yeah. So if I said const x, if I'm passing constant x and I set y equals constant x and I say y equals y plus 2, that will work. I have this specifically to show that the same functionality can cause problems in the yes, but that would be a good logical way of passing to it. Yes.
So does the function have the ability to distinguish if as a parameter const int versus just a regular?
No. Yeah. So I will comment all these all out and show you the difference here. So first, let me run clear. I'm going to run make ambig. And the first error is redefinition of int with constant. So it says previously defined here. And there it also says assignment of read-only parameter I. So now it's saying the const is a problem. And then the crucial thing, this line of code here, I mean, this line of the compiler error call of overloaded print ampersand is ambiguous. It cannot tell the difference. And then we start getting these. So C++ will add a lot of these kind of notes afterwards. If you see it in red, that means it's an actual error. If you see it in blue, that means what it's trying to do is it's trying to find the right version and make recommendations. As we start building classes and we start using class templates, what you're going to see is that you might make one error and it has a couple dozen of these recommendations and it's going to look massive. But I promise you it's not. And in fact, I'm going to, when we get to that point in the lecture, in the lecture schedule, what I'm going to do is I'm going to make several deliberate template errors that make compiler error statements that look enormous and scary, but are really just one small change. So if I were to comment out here, so this will follow up on your question. If I comment this out, it's still going to say previously defined here. And it's not going to be able to tell the difference between const and non-const. Okay. Scary compiler errors. Okay, so does anybody have any questions on function overloading before I get into classes? All right, so last week, I went on this whole spiel as we started C++, that C++ is an object-oriented programming language. And I talked about these 4 pillars of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. What we're going to learn today is 2 of these. We're going to learn in more detail about the idea of encapsulation, and we're going to encounter our first really detailed version of abstraction. So if you remember, we had this example where we talked about a student, and the student had different tasks they could do, and we could come up with different things for the student, with a junior or a senior. We could have a different definition for a person based off of a person was a staff member or a faculty or a student. And all of these groupings could put it into some sort of definition of an object. And in C++, we're going to call that definition of an object a class. And so what are classes? And I put in a little bit of detail, but I'm happy to go over this analogy again because it's very helpful. Classes are methods that are used to manipulate data, and we use them to be able to simulate objects and how these interact, right? So you have student has method, ask a question. You ask me a question. I don't need to know, in order to answer your question, I don't need to know all the thoughts that went through your mind before you asked the question, right? I don't have to hear Dr. Morrison is making absolutely no sense this morning. I hate this class, right? I don't have to hear any of that stuff. I just heard the question and I answered, right? There's all kinds of things that go on underneath the hood. In this case, you only have to show the programmer what it is that they need. So we saw you worked with standard vector, you did the lab over the weekend, right? So you did a function called pushback, right? And in this function pushback, we have learned that with pushback, you can put as many elements as you need onto a dynamic array, right? You didn't have to know what was going on underneath, right? You didn't have to know how the memory was being reallocated. You didn't need to know how things were being done. You didn't need to know how things were being deleted. All you needed to know is that I had some sort of array that I can change, and then when I get to a certain size, I want to put more stuff onto it, right? So that is an example of abstraction. It abstracted a lot of the complexity away from it. Classes allow you to do that, and this provides safety. You can make sure that the person who's using your class should only be doing the tasks that you want them to do and nothing more. So we are still going to split functions into .cpp and .h files, but what we're going to do is we're going to do a class definition. And in the class definition in the .h file, we're going to define the class, and we're going to have the declarations of the class methods. In the .cpp file, we are going to have the class method definitions. And the template to do this is very specific, and I'm going to walk you through it, okay? So the first thing is just like before. In any header file, we have pound if, not defined, define, and end if, just like we were doing in C. This allows you to provide protection to your classes. It's the whole reason why we do this header file guarding in the first place. So that way, when you have things that are private, they stay private. The next thing is that we're going to have what I have here for the function class name function definition. And what I want to do is walk through each with you step by step, because this is going to help you understand classes as we start building our class definitions as well. So what's going to happen is in the .cpp file, whenever you have a class, you're going to have first have pound include and we'll just say class.h, right? Just like we were doing before the header files in C. But because it's going to be a class method, we have to explicitly state that the function that's there is a member of the class. And so the first thing we do is we have everything. So everything I've underlined just now is what we've covered up to this point. We have a return type, we have a function name, and we have some preconditions. But now I'm going to call it a method name because it's a member, it's a function within a class. The other thing we need to do is we need to have the class name in front. So in the .cpp file, you're going to see class name : method name. That's the same thing with standard cout or standard vector. See that? So what the standard is doing is that there is a C++ standard that defines all of these classes. And when you define a version of that, you're defining an object from that library. In very much the same way, when you do a C++ class, you are defining your own library. And so that's how we'll do this. So I have two examples here. I have a class point. So we're going to do the same thing. We're going to create a point and then a line. And we're going to print out everything else, the type definitions for coordinates. And so you see that I have coordinate point : means that it's a member of the point class. I'm sorry, it's a method of the point class. And the method is called getX. And the second one, I have void. I have point : set X. And I'm reading a coordinate in X. Okay, does this make sense so far? Let me check the chat, see if there are any questions. So the first type of class method that I'd like to introduce you to is called a class constructor. And it's unique and it's specific to classes. The whole idea of a constructor is that it's a member function that it's used to create the object. So for example, in the point class, we have two doubles, right? When I call a class constructor, this will allow me to allocate that information onto the data heap and simultaneously take it or not take in inputs to send those information. So I'm going to just I'm going to describe that distinction in a moment. So whenever I create an object, it's going to automatically call this constructor. It's going to automatically create a pointer that's going to point to those locations on the data heap to get that information. And the whole idea is that it's used to initialize some or all of the data members or perform any other type of initialization that the object requires. So what this is going to do is we are going to define the class members when we create our constructor. So we either are going to call what's known as a default constructor, which just creates an object and that's the default version of it. So for example, if I create an integer and the default constructor for an integer is going to be all zeros, so the default value of an int is going to be 0. We can indicate what our class default constructor should be. We can do overloaded constructors. We can have multiple constructors in order to build a particular class object that we want things to do. The other thing I want you to note before we continue is that constructors do not have return types. The return type doesn't exist in there. You don't write one. You just, what is actually being returned is a new object. And what that represents is the same thing as if you did float F1, right? Remember in C, you could define a variable and just name it and not have anything there. When you define a default constructor, you can do the same thing with your class. Does anybody have any questions on this before I continue? All right, so default constructors. A default constructor means you don't have any inputs, and the compiler supplied default constructor initializes each member to its default value. So it would be 0. Or if we have a class aggregated, and I have a default constructor for a point, and then I call lines default constructor, it's going to call the points default constructor. But I can also overload them to do other things. Another crucial part, if you implement any constructor for your class, it will not supply a default constructor. So if you have a constructor that takes an input and you try calling the default constructor of the class object, it's going to throw a compiler error because it does not provide that for you. This is a good example of the computer doing precisely what you told it to do, not what you want it to. Yes.
Can you give an example of
Sure. I'm going to go into code example, and that should help make things clear. I'm kind of giving a lot of lead up before I actually start digging into the code. Are there any other questions? Okay, so let me go into the point class. I'm going to go over it step by step, and this will hopefully clarify things. So first, I'm going to go into point.h. So in point.h, I have the header file guarded, and then I have type def float coordinates, so I'm able to do that. For a class, before you do anything else, you just have class point and then a brace. And if I scroll all the way down, you're going to see that I have the brace and then a semicolon after. And so you can see that I have it coming. This is really important. When I'm writing C++ code and I have to write my own class, the very first thing I do, I write class, the name of the class name, I do the two braces, I do the semicolon. In fact, I'm going to show you an example when I compile, when I take the semicolon out, about how hard that particular issue is to find. So now what I want to do next is I want to scroll back up to the top and explain the, explain the design of this class. So you have class point, and then we have this new keyword private. This is different than anything we saw in C. One of the challenges in C was that at the time of the invention of C++, that all of the variables were available to anybody. And in fact, you did that when you did your, especially for those of you who finished homework 5, whenever you had to access a member of the struct, you just said dot whatever it was, right? And you were able to access everything. But that's not always a good thing. Sometimes what we want to do is we want to protect our data. And in this case, we've defined these two floats as private, meaning that we cannot just access them. We have to write some sort of method in order to be able to access those. Does everybody kind of get that idea? Okay, so now, first thing I'm going to do is I'm going to highlight these two constructors. So these are inside the .h file, and we do not need point, colon, colon in front of them. I have defined a default constructor, and that is the first one. You can see that it has no input. And then the overloaded constructor has two inputs of two floats. Does everybody see that? The next four methods are get X and get Y. And what we're going to see is that this will return a value of the float when I call it. And then I can call set X and set Y. if I want to update them in real time. Now, the thing I want to point out in C++ is that you only want to write get and set methods for things you want the program to be able to get or set. Otherwise, don't write them. Make the data protected. Once it's defined and you don't want somebody messing with it, don't let them. You have the power. And then the last thing I have is a print point. All right, yes. Sure. Okay, so let's say that I don't want anybody to be able to, once I construct the point, I don't want anybody to ever be able to change the value of X. Because that's just an example, right? I could do this. You're not allowed to change X, no matter what you do. Right? So what you can do is if you go through your design and you say, I don't want somebody to be able to access this. I don't want somebody to be able to change this. It's not necessary for them to be able to change this. That's another example of a good time. You want to do that? Then you don't have to write a get or set method for them to have to do that. Did that address your question? Yes. Yes. Okay, so we're going to go into a lot of detail about here in a moment. Okay, so now it's almost like you were leading me right into how we're actually going to construct and define these class objects. So first, I have this one highlighted here is the constructor. I can just define it as 0 and 0, and here what I have is a member initializations list. So let me go into. I had member initial. Okay, member initialization list. So I'm defining a constructor where I'm bringing in 0 or more inputs to the constructor. If 0 is default, otherwise I'm overloading it. After that, what I'm going to do is I'm going to write a colon. So the way this constructor template works is class name, and then I call it again. So this is the constructor. I have the inputs, and then what I do is I put this colon there, and inside I would have two private members, origin and destin, right? And they have to go in order that we define it in the class. So point origin in. The way this template works is origin in, comma, destin in. And here's an equivalent where I'm bringing in two values to a function where I set origin equal to origin in and destin equal to destin in. So this means, so let me delete this. This right here in a C++ constructor is equal to that. Does everybody see that? And likewise, I would do comma, destin in. The reason why C++ has this member initialization list is because when you construct an object, what you're doing is you're creating a pointer that points to the location on the data heap, right? So by putting it in order, I will allocate this memory, and then I'll start out at point. I will put in those values. I will perform pointer arithmetic. I will put in more values. I'll perform pointer arithmetic and keep going until I'm done, right? So what the member initialization list is doing is by putting it in that order, you're making the code run more efficiently. You're starting here, you put this information. Now we're done, I put this information, right? What I'm not doing is I'm not going, all right, I'm going to put this here, and I got to put this here, and I got to put this here, and it's haphazard, right? So this member initialization list allows you to do this in a way that is efficient in the program. Does that make sense? So what I want to do is I want to show you point, and this will hopefully go back to address the question from earlier, that it's not just about establishing where the code is and operations can do it on. Now we're starting to get into how can we do things the most efficient way. And in C, the way we have to do that is we have to write all these pointers and move things around. And we have to go back to the Margaret Hamilton, having her book all the way up to her head, right? This would require a lot of work in C. And so what C++, by doing this class is allowing us to say is, one, I want to be able to define a point, and I can have as many points as I want. Instead of having to do another pointer and allocate a new thing, the point will say, all right, I'm going to allocate a new point object, and I'm going to set these coordinates equal like so. And so this allows me to do this in an efficient way that's relatively easy compared to C, right? And so that's the first, so that your question has several follow-ups. So I'm going to get back to more of things. So what I would like to do is next show you the constructor. You'll see that it's in the order that I have it in the .h file. So in the .h file, the private members are defined as X and then Y. Does everybody see that? So I do the same thing in my point.cpp. In my member initialization lists, I do it X and then Y. In point, I do it X and then Y. And so if I do it the other way, I compile it, that's actually going to give me a compiler error. And so from here, I now have coordinate point get X, which is now a member of X, and then get Y returns Y. And then I have set, and when you have this point here, you can call members inside of that class. You see that? Because I have that, that corresponds to the specific point. And you do the same thing for Y. And here I can return Y and return X. And then if I do print point, we'll see that I have standard C out and I can print the X and Y location. So the next thing for line, let me go to line.h first. In line.h, I have private origin and destination. And here I actually have 3 constructors. I have a default constructor for line. I have a constructor for line that has 2 points. And I have a constructor that has 4 coordinates. So if I have 4 coordinates, the 2 are supposed to be for an origin and 2 are supposed to be for a destination, in fact, I'm going to create 2 pointer objects, but I don't need 2 point objects input. I can make multiple constructors based on how it is I would actually define a line. And so likewise, I have point for origin and destination, get slope, and print line. And here I define everything in the .header file, means in the .cpp file. So I have a constructor, colon, member initialization list. And here I'm actually creating 2 points that are at the origin of the Cartesian coordinate plane. So that is my default constructor. So the line itself is just 2 points at the same place. My first overloaded is class, colon, line, means this is a constructor. I take in 2 points, colon, origin, destination, and then after that, no colon, no comma after the last one, but I should have braces. And the reason why we have braces is that braces in C and C++ are used to define procedures, right? Going all the way back to lecture 1. So this is a procedure saying I'm going to do a member initialization list, and then I have a procedure saying that I'm going to actually create the object. Here I have 4 coordinates in this constructor, and then what I do is I call origin, and I set that as, and I create a point. There, does everybody see that? So I'm calling a constructor within a constructor. And that's exactly how we would actually create a line in the real world. What I would do is I would say, all right, well, I have an X and Y. And so I've coordinated two, and then I would create 2 points. And then, well, you got the idea. So you can see that C++ and this object-oriented programming is starting to take advantage of these constructors to build things the way we actually do when we actually think about them. We have get line. Here I have get slope. And I calculate the slope based on the destination and origin. And then I print the point. I print the line. And I do this by calling print point, comma, space, print point. And so the first thing I want to do, and this is going to get back to a question that you asked a little earlier about default constructors. So with a default constructor, here I have point 1, and that's all I do, just like int x, float f1, things that you've done before. With a class that we have now defined, I can now just say, give me a point. And the benefit is, just like with an integer and a float before, we can define it later based on information that we have. Now, one thing I would like to show you is what happens if I do this. This is a very common new programmer mistake. When you call a default constructor, you do not need to put these parentheses. And so what I'm going to do is I'm going to make class intro, and this is going to generate a pretty nasty looking compiler error. And you can look at this, and if you're inexperienced at programming, go, oh my God, what did I just do? Oh, Dr. Morrison, I need an extension, help. Right. And it says request for member print point in point 1, request for member set X, request for it, and it doesn't seem to make too much sense. But we see that it's trying to request everything here. But if we go down to the notes, we start to see what the compiler error states. See, it's starting to say candidates are, and it's starting to ask us for constructors. Does everybody see that? Like, oh, you could use this constructor, or you could use this constructor. And this is no known conversion from argument 1 of point to point. And so that's the hint right there. And so what that's saying is when you do a default constructor, that even though in the default constructor, so we're going to go back to point, even though in the default constructor it has parentheses afterwards, we do not need to do that in main. And so what I would like to do for the last 2 minutes of lecture is quickly walk you through this piece of code and describe what's going to be output based on what is being done in the main function. So the first thing we're going to do is we're going to call point 1 with a default constructor. So I'm going to call print point. What do we think is going to happen here? What's going to print out when I call the default constructor? Let me check to see if anybody in the chat knows this too. What did the default constructor for point define X and Y as? Yes. 0. So when I do this, it's going to print 0, 0. Next, I say point 1.set X is coordinate 3.1, and point.set Y is coordinate 6.2. And so what is this now going to print out here? What do we think this is going to print out? Is it going to print out 0, 0 still? What's it going to print? Absolutely right, 3.1 and 6.2. So now I create a second point, and I'm going to print this out, and it's negative 1.1 and 5.3, so it's going to print that out. And now I have a line that calls the default constructor. And so forgive me, I'm going to go through this just a little fast because it's the end of lecture. So since it's the default constructor, it creates 2 points after origin, it's going to say 0, 0 for both. And then line 2, I have it as point 1 and point 2. And then for line 3, I have point2.getX, point2.getY, point1.getX, and point1.getY. So what we're going to see is that line 2 and line 3 are in reverse. So I've reversed the line. And then the last thing I do is I call getSlope each of these. So if I run make class intro, first I should actually update my code. Got to unbreak the code. Okay, and then class intro, and then it prints everything out. So what I'm going to do to start Wednesday's lecture is I'm going to go over how to make files using classes, and then we're going to go into a lot more detail about how to construct classes and how we can take advantage of them. So on that note, if no one has any other question, this is 10:01, you are dismissed.